Hey guys, we have an interesting discussion going on Project Farm's channel in the threads. Anyway, a lot of people have different theories about the volatility of gasoline in containers. I'm going to make this real quick because I brought this down to 20 degrees and it's actually starting to warm up, and right now it's at 30 degrees and this is gasoline. And I'm going to see if you could drop a lit match in 30-degree gasoline without it going off or without it igniting, because the lower temperature should reduce the amount of fumes in here. My theory is if the lit match makes it to the fume layer in that gasoline, it's going to ignite. But if you light the match and throw it and it goes out on the way, the match becomes an ember and will not make it down to the fluid. The other thing of gasoline that I have there is at room temperature. So let's see what happens real quick. By the way, safety glasses, fire extinguisher. Okay, actually that went out. But of course this is also old gasoline. So lower temperatures reduces the fumes that's produced by it, and it's not as volatile at lower temperatures. But there are still fumes produced by that gasoline. There's just not enough fumes mixing with the oxygen that's in the jar to come up to a combustible level, and that's at lower temperatures. So there you go. Lower temperatures reduce the gasoline fumes, and eventually the fumes will build up in this jar enough to where it will become volatile again. But what happened is I reduced the amount of fumes that was in this jar by reducing the temperature of the gasoline. Now if I leave the lid on it and leave it at 30 degrees, those fumes are going to build back up again instead of dispersing through the lid, and it will become volatile at 30 degrees. Now, the room temperature gasoline should ignite pretty quickly and pretty easily. So I'm going to have to be real careful here. Oop, I missed. There you go. Now that's room temperature gasoline. So if it's room temperature, or if it's outside temperature and you throw a match in gasoline, it's going to ignite because the molecules in that fuel have not been slowed down, and it's still producing a decent amount of fumes. But when you slow down the molecules in that gasoline, they're not bouncing around from on each other, and you're not having as quick of an evaporation process, and that's why you're reducing the fumes that's produced by this gas. Now that I've had the lid on it, give it a shake. That speeds up the molecules. It should be about 35 degrees at this point, and it should ignite if I can hit it. See? And that's what happens. But if you close the container for a moment, let the fumes actually build up so that you're in a combustible state with the fuel-air mixture, it will ignite when you throw a match in. But if you drop this down to 30 degrees or below, which I actually had it down to 5 degrees, and let it slowly warm up to 30, well, quickly warm up to 30 actually, sitting outside here, it didn't produce enough fumes in an open container in order to make it combustible. But if you put the lid on the container and let it warm up to 30 degrees from 5, it will produce enough fumes and it will ignite. It won't be as volatile at ignition as it would be at room temperature, but it will still be an ignition. So you've really got to play with how you set it up and how you try this, because if you do it exactly right, it won't ignite. But if you let it slowly warm up with the lid on the container, it will ignite. So, in a sense, if you have a bucket of gasoline and it's sitting outside and you throw a match in it, it's going to light off. But if you get it real cold and you let the fumes that are in there disperse before you throw a match in, it won't. Thank you for watching.